Most of us look up at the night sky and see a calm, steady band of stars, a peaceful, cosmic home that has existed unchanged for billions of years. But nothing could be further from the truth. Beneath that serene glow lies a dark, dynamic history of cosmic conquest, galactic cannibalism. Over 13.6 billion years, the Milky Way has grown from a tiny, fragile cloud of gas and stars into a majestic spiral galaxy, spanning 100,000 light-years, holding between 200 and 400 billion stars. It did not achieve this size by gentle growth alone. It became a cosmic giant by hunting, capturing, tearing apart, and fully absorbing smaller satellite galaxies that wandered too close to its immense gravitational pull. This is not a story of random collisions. It is a systematic, relentless process, written into the very laws of cosmic evolution, one that continues, even as we speak, shaping the stars, the structure, and the future of the galaxy we live in. To understand galactic cannibalism, we must first grasp the hierarchical model of cosmic formation, the most widely accepted theory of how galaxies grow. The early universe, just a few hundred million years after the Big Bang, was filled with countless small dense clumps of gas, dark matter, and young stars. These were the first dwarf galaxies, tiny building blocks, scattered across the expanding cosmos. Gravity, the silent architect of the universe, began to pull these small systems toward one another. Larger clumps attracted smaller ones, and over billions of years, mergers built bigger and more complex galaxies. The Milky Way was no exception. Its early days were defined by repeated mergers, but as it grew more massive, it transitioned from a merger participant to a cosmic predator, dominating its local region of space and feeding on the smaller galaxies that became its gravitational captives. These small systems, known as satellite galaxies, orbit the Milky Way, like moons orbit a planet, trapped in an inescapable spiral toward destruction. The engine behind this cosmic predation is the Milky Way's invisible dark matter halo, a vast spherical cloud of dark matter that surrounds the galaxy's visible disk and extends hundreds of thousands of light-years into space. Dark matter does not emit or absorb light, so we cannot see it directly, but we can measure its gravitational influence. This halo acts like an enormous cosmic net, exerting a pull so strong that any dwarf galaxy entering its reach is quickly captured. Once trapped, the satellite galaxy begins a long, slow death spiral. As it orbits closer to the Milky Way's center, tidal forces, the difference in gravity between the near and far sides of the small galaxy, stretch and distort its structure. Imagine pulling a piece of taffy until it stretches into a long, thin strand. That is exactly what happens to a dwarf galaxy falling prey to the Milky Way. Stars, gas, and dark matter are stripped away one by one, forming faint, graceful structures called stellar streams that wrap around our galaxy like ghostly necklaces. These streams are not just beautiful cosmic features, they are the fossilized remains of galaxies. The Milky Way has already devoured silent witnesses to its violent past. For decades, astronomers suspected the Milky Way had a history of eating smaller galaxies, but we lacked the tools to prove it. That changed in 2013, when the European Space Agency launched the Gaia satellite, a space observatory designed to map the positions, motions, and chemical compositions of over 1 billion stars in the Milky Way with unprecedented precision. Gaia did not just map stars. It opened a new era of galactic archaeology, allowing scientists to read the Milky Way's past like pages in an ancient book. In 2018, a team led by astronomer Amina Helmi made a groundbreaking announcement. Gaia had identified roughly 30,000 stars moving in retrograde orbits, traveling in the opposite direction of nearly every other star in the Milky Way's disk. These stars had different chemical signatures, different ages, and different trajectories, proving they were not native to the Milky Way. They were the remnants of a massive dwarf galaxy that collided with the Milky Way between 8 and 11 billion years ago. Scientists named this lost galaxy gaia-enceladus, also called the sausage galaxy because its torn remains formed a long sausage-like stream across the halo. This single merger was one of the most significant events in the Milky Way's history, contributing a huge portion of the stars in our galaxy's inner halo and reshaping its structure forever. Gaia's revelations did not stop there. The satellite's data has since revealed evidence of at least 6 fully digested dwarf galaxies, each absorbed during a different era of the Milky Way's growth. But the most chilling chapter of this story is not in the distant past, it is unfolding right now. The Milky Way is currently in the process of devouring its closest and most well-known satellite galaxy. The Sagittarius dwarf spheroidal galaxy. Discovered in 1994, this small elliptical galaxy lies just 70,000 light-years from Earth, close enough to be considered a cosmic neighbor. For more than 5 billion years, it has orbited the Milky Way in a steep polar path, repeatedly crossing through our galaxy's dense stellar disk. Every pass subjects it to unbearable tidal forces, stripping away millions of stars and leaving a vast, looping stellar stream that stretches more than 1 million light-years across the sky. The Sagittarius dwarf galaxy is already barely holding onto its core structure. Within a few billion more years, it will be completely torn apart, its stars scattered across the Milky Way and fully assimilated, as if they had always belonged here. It is a slow, silent destruction, no explosions, no flashes, just the quiet, inevitable pull of gravity, erasing an entire galaxy. Another recent victim is the Canis, major dwarf galaxy, even closer to our solar system than the Sagittarius system. It is so close that some of its stars lie within 25,000 light-years of Earth, making it the nearest known satellite galaxy. The Canis major dwarf galaxy is nearly fully dissolved, its stars forming a dense ribbon-like stream that wraps around the Milky Way's disk. Astronomers have also identified the Aquarius stream, a young stellar stream, just 700 million years old, cosmically speaking, a fresh meal, still in the process of being digested. These streams are everywhere we look in the galactic halo, more than a dozen, confirmed so far, each marking the grave of a once independent dwarf galaxy. Even the stars we see in our night sky hold clues. Some stars, with unusual chemical abundances, rich in heavy elements like gold and uranium, were born inside dwarf galaxies and later taken in by the Milky Way. Our own sun might carry tiny traces of these lost worlds connected to galaxies that ceased to exist billions of years before Earth even formed. This might sound like a story of cosmic violence, but galactic cannibalism is not cruelty. It is simply how the universe works. It is the primary engine of galaxy evolution across the cosmos. Every large spiral galaxy, from the Andromeda Galaxy to distant spirals billions of light-years away, grew by absorbing smaller systems. The Milky Way's behavior is not unusual. It is standard for a galaxy of its size. And this story is far from over. In about 4.5 billion years, the Milky Way will collide and merge with the Andromeda Galaxy, our nearest large galactic neighbor. This will be a major merger, not a case of one eating the other, as both galaxies are roughly the same mass. Together, they will form a massive new elliptical galaxy, often dubbed Milky-Dromeda, erasing both original identities. But until that day, the Milky Way will continue its quiet feast, capturing any small galaxies that wander into its gravitational grasp, adding their stars and material to its growing structure. When we look up at the Milky Way now, we should not see just a band of stars. We should see a living, evolving predator, built from the ruins of dozens of smaller galaxies. We should see stellar streams as ghostly monuments to lost cosmic worlds. We should see our own place in this story, humans, living on a planet, orbiting a star, inside a galaxy that was forged by conquest. This story fills us with awe, not fear. It reminds us that the universe is not static or silent. It is dynamic, dramatic, and full of hidden histories, waiting to be uncovered. The Milky Way's dark history of galactic cannibalism is not a tale of destruction alone. It is a story of creation, of how small pieces come together to make something vast and magnificent. Every star in the sky, every planet, every moment of life on Earth is connected to this ancient, ongoing cosmic dance. Please like, comment, share, and subscribe to the channel